Hi Astro Addicts, my name is Tim and welcome back to Astro Addict and welcome back to explaining PixInsight. In the last video we talked about the general one-shot color integration workflow and now we continue with the post-processing of a one-shot color image. You see a blank screen in front of you because I want to show you the saving options in PixInsight. When we left off in the last video there was the integrated image and the process icons. We can save the entire project and load an entire project. These projects are bundles, meaning these files are folders where all the data is stored. I have the Pac-Man Nebula tutorial data here. It will load pretty fast and here we are back again, exactly where we left off. As mentioned in the last video, we now have to perform the background modelization. This basically means getting rid of the color cast, the light pollution, and every possible form of gradients in our image. I already prepared the process icons for this process. I will load them in. Note that PixInsight will not automatically merge these old with the new icons. You have to press merge icons to actually get them together on the screen. Again, a good reminder, the image we're looking at is still linear. You can see it on the small green line on the side here. The image is linear and the auto stretch is applied, only a preview. The background modelization needs to be done on the linear image. To get rid of this color cast, we have two separate tools. We have the dynamic background extractor and the automatic background extractor. Both of them work in the same way. We give them some samples, or the samples of the background are measured automatically, and they will either subtract or divide the calculated background. Let's start with the most basic form of the extraction, the automatic background extractor. You can basically leave all the settings at default. They work pretty well. The only thing we have to change, the target image correction. We have subtraction and division. A little bit of background, literally. Gradients in your background can either be additive or multiplicative. The most persistent multiplicative gradient is vignetting, which we already corrected with the flat frames. So generally no need of division. I will choose subtraction because light pollution in general and this color cast is only additive. It adds onto your image, nothing more. I will not choose normalize. I will show you the background model. I will not replace this image by the new one. I will always have it up here so I can go back if something went wrong. I will choose subtract and apply this to the image. And just a few seconds later we have the subtracted image right here in the background. Let's look at the background, see if it's good. We see it's a little bit brighter in the middle. Let's see if it's actually worth it. You might see it looks pretty good. The nebula got a bit bigger because we see more of the outside nebulosity. But one thing that I still don't like, which I see quite often using the automatic background extractor, this small red halo. Now this is still there if I use division. That's why in most cases I don't like using the automatic background extractor. Try to use this tool if you have lots of nebulosity and you can't get any proper background samples. I will close this one. The first tool, the automatic background extractor, and now the dynamic one. The dynamic tools in PixInsight are a bit weird because they are linked directly to your image and you can't perform anything else while performing them. The image is now linked, you see the crosshair in the middle. We can now place sample points. I will zoom in. While holding down the spacebar and dragging with the left mouse button, I can pan around in the image. And I still see some very annoying distortion at the edges. I don't like it. I think my field flattener is off. I will place a sample point right here. You can see the pixels in the sample point. Exactly like with the automatic extractor, the default settings are just fine for me. I will now place a couple of sample points, maybe 10 or 20, maybe between 20 or 30. And you always want to choose areas with exactly 0 nebulosity and no stars. It gets rid of the stars as you see right here, but try to hit areas with no nebulosity because it will subtract those as well. Choosing something next to the object can also be quite fine. I will stretch it even more to see if I have nebulosity here. No, I don't. And in the end of this video, I will show you a special technique where you can directly see if there's nebulosity in your image. And by that I mean, sometimes when you have a lot of nebulosity, let's say you're imaging the Crescent Nebula, for example, very close up, there's nebulosity almost everywhere in this image. Trying to get good background samples, for example, in the Crescent Nebula is very hard, and I will show you a technique where it works very well later. I now place 22 sample points, I think maybe one here. Again, I will choose subtraction. I don't need the background model this time, and apply. It only takes a few seconds, let's see. Now this is what I like to see. There are some darker areas in the background, but we can get rid of those areas later. And I see some yellowish tint over here, but that doesn't matter. At least we don't have the red halo around it anymore. Well, these are the tools for the background extraction. Some tips, if you are still not quite happy with these tools, you can perform, let me close this one. You can perform some intermediate steps to get this better. For example, I will keep this one open. No, actually, let's look at before and after. I will again use the automatic one. Now we have the basic workflow with this tool. Next up, I should have used the crop tool before, the dynamic crop, to get rid of the edges, but it doesn't matter really. I think the edges look pretty fine. No, yeah, they look pretty good. A little bit more noisy because of less data, but that doesn't matter. This image was created using only the automatic background extractor on the integrated image. Now, let's get some more steps into this. I will extract the channels of the integrated image using the channel extraction tool. I will choose RGB and apply. Now we have all these channels in black and white. The blue looks nice. Green looks a little bit less, I suppose. And red. Wow! Now the red channel has the most data, of course. The hydrogen nebula in the filter works well. And now we can apply the automatic background extractor to each and every single one of these images. Apply to the red. I will drag this red, apply it over here. This is the background. Yeah, here you can see the halo, which this tool creates. Again, we don't need these ones now. Get rid of this one. Apply to the green. Looks good again, a slight halo, even in the green channel. Apply to blue. And almost no halo right here. Now we applied the automatic background extractor to every channel of the image, and now we will combine the channels again. Choose RGB. This again is the channel combination tool. I will choose the red, I will choose the green and the blue. Hit, I think one of these has to be open for this tool to work. Hit apply. Hit this one, alright. And let's look at the before and after. This one looks a bit different. We don't need these ones anymore. If you only compare the nebula data, it hasn't altered a lot. Maybe it's a bit more pinkish, I think, and a bit more light. The halo is still there. The background is definitely darker, but much more purple, less green. To get rid of the halo, we could also use the dynamic background extractor on each channel. It will take a lot of time, but it's definitely worth it. If you are not happy with the results on the integrated image, try to apply these tools to every single channel. And now, let's say, a small trick I discovered recently in the PixInsight forums. With these tools, and especially with the dynamic background extractor, you want to provide samples with absolutely no nebulosity in them. You could stretch the image more and even apply maybe a curve stretch to see everything. And even here we see maybe some nebulosity up here, maybe I shouldn't have chosen some samples, but how can we see this in images where there's so much faint nebulosity that it almost covers the entire image? Well, I found this technique, as I said on the forums, and I instantly loved the idea behind it. How do we get an image of the Pac-Man nebula where we see every nebulosity? Let's say an image of maybe the best telescope in the world. It's not that hard. I have on my second monitor right here, I will drag it over. Maybe you heard in some of my videos before about the Digitized Sky Survey. Data from the European Southern Observatory, the ESO, as you see up here. I will link this page right here in the description of the video. Over here you can enter the object name and the size of the image you want to have. And you can download the entire image as a FIT file. This tool is more for scientific studies, let's say, but this is amazing. We can take a look at every object in the entire sky, northern, southern hemisphere, it doesn't matter. And even better, this website is integrated into PixInsight. I can go to Script, Utilities, and the DSS Image Downloader script. And this is where this entire amazing part begins. I will choose NGC, New General Catalog, and if I remembered correctly, the Pac-Man is 281. I want a very large image, please. 120 arc minutes is the maximum you can download. I hit OK. You can see in the console it's downloading the data right now. It's quite a lot of it. It will take a few seconds. Hang on. Wow. I assume we can't really see much here. We have to apply some adjustments to it before, but we can already see a perfectly beautiful image of the Pac-Man right here. I will mirror this to match my Pac-Man here. I will rotate it counterclockwise. I will at some point explain the histogram transformation in these videos, but I will just move the black point further in and create some contrast. Let's look at this. And this data was, as you can see, taken with a mirror telescope. There are maybe some satellite planes in it. Again, this data is not made for photographic experiences. It's made for scientific purposes. And I have to say, I love the star spikes in every single image. But I think the telescope at the ESO is a bit out of collimation, just a tiny bit. But let's not worry about that. I think this looks fine. Maybe I can do a little bit more contrast, darker background, like this. No, this was bad. I think this is enough. Yes. Now we could see where there's the nebulosity, because these images are taken in absolutely zero light pollution, which is incredible. Now we could place the sample points of the background extractor in this image and apply them to the left. But applying those to different images is almost impossible. So we have to register these two images. The tool you want to choose in this case is not the star alignment tool, it's the dynamic alignment, which is a bit wonky sometimes, so let me explain. It's again a dynamic tool, so it works awful. No, just kidding. It works very complicated, let's say. And again, already it doesn't work as I want it to be. Source, integration, target, this one, right. The aligned images have already been chosen. Sometimes you have to click in the first one and then in the second one to get the source and the target. I will now choose a good star from this image. And by a good star I don't mean the bright one, because the sample boxes are very small. I will increase this to 50 and 50. Let's say we want to pick a, and again I already misclicked. You can't use the spacebar in here, which is annoying. Which star can we choose? The bright one to the left, and then there's this small one. Now as it chose the big one. This won't work. The small one, please. I chose the small one to the side of this bright one. Now let's look for this in here. The software thinks that I chose this star in the right image, but that's not true. Let's show them the right one. I will zoom in. And while pressing Shift, I can drag this one onto the small star. And I think it shows the right one. Yes. Now these stars will be aligned, and we have to choose at least 3. I will now go to this one, the bright star to the right, and again a tiny star to the right. Did it choose the right one? No, it didn't. That's typically what you get. Yep, it found it. Now let's go up here, and between these 2 bright stars, let's choose this one, and it should be, yes, it should be already locked in. We have 3 stars. Let's register these images. And this is amazing. I can close this one now. Now we have the perfectly aligned Pac-Man DSS image. How can we now transfer the points to our image? We can't just put them over there. And here's the genius idea. Since these images are exactly the same sizes, can now apply this as a mask. And I will talk about masks again later. It's a very important feature in PixInsight. How to apply masks? You just take from the mask you have chosen, you drag the identifier under the image on the bar here you want to choose. It's not very intuitive, but it works. I will minimize this one. Now we can invert this mask, enable it, show it. It's still there, it's just not shown. And the rendering mode, well, no. I like to go with replace. The basic, let's say, a sentence you can keep in your head for masks: light selects, dark protects. Or as I like to call it, LSD. Light selects, dark something. Now we have this as a mask, and we see where even the tiniest bit of nebulosity is right here. Stretching this will not give us anything. We now have every single bit of nebulosity and can apply a perfectly weighted dynamic background extraction on every image we want to choose. And this is incredible. We could now choose these tools. There's nebulosity up here. I typically in the previous steps without this tool, I think I placed a sample point here. Bad. Now we can avoid every nebulosity, and every star, even the smallest stars, appear in this telescope. Look at this. The resolution is incredible. There's some nebulosity here. And now I can just go around and pick everything I want to choose. Now let's disable the mask, apply the tool. It's now doubled in size, let's bring it back. This doesn't look very different to the first dynamic background extractor we did on this image, but there is not much nebulosity in this one. but you can use the digitized sky survey data if you have lots of nebulosity. Just a small hint, which I was instantly amazed by. Alright, I think that does it for this video, the backward modelization. Not exactly very complicated. I think it can be done pretty fast if you have the routine, but these initial steps can alter your final image very much, and keeping this simple but efficient is very important in my opinion. In the next video I will talk about deconvolution, the video I have the most fear to do it because I still don't have the skills to perform a good deconvolution, but I will show you the basic premise of what I know about it and how I do it. And this video will be very long because deconvolution is A, a lot to explain, B, it takes a lot of time to render, and C, I still can't, as I said, perform it very good at this point. Alright, this is it for today. Stay tuned for the next part, the deconvolution. My name is Tim, I'm an Astro Addict. I wish you clear skies, and may the night be with us.